I'm Bob Brecha. I'm in the physics department at the University of Dayton, and I am also a professor in the Renewable and Clean Energy graduate program and coordinate the Sustainability, Energy, and the Environment Initiative. Einstein, I think, was motivated by at least partly by trying to clear up some remaining mysteries. He wasn't the only one, but at the end of the 19th century, physicists had perhaps gotten a bit overconfident, thinking we've got it all down now. It's only the details, and everything is engineering after this. So he started looking at more detailed, or did some more detailed thinking about the edges of physics. It was like he was pushing to the very edge of what we could think about and had been able to observe. He was looking at the speed of light and light waves, and thinking about light waves and how they would move and what it would be like to ride on a light wave, and how some of the how you could basically push the existing theories into a place where they didn't make sense anymore. They didn't work anymore. And he made some very simple thought experiments and talking about the what happens if objects start moving near the speed of light. And out of that, he proposed a couple of simple postulates that were earth-shattering in the end. They sounded simple and harmless, but if you followed through the consequences, then they weren't. They were very counterintuitive. But that, along with some other ideas that he had, they tended to clear up, if you accepted them, they would clear up other things that happened in physics that weren't explicable. So you had to accept that. Then the next point becomes, we've got to do experiments. I mean, if you're going to, it's easy enough to just say, oh, speed of light is constant no matter what the state of motion of the source is. He said, okay, we have to do tests. And so then that became the next piece. His work was very controversial because it was harder to test. It gets harder and harder to test as you approach these extreme limits. And Kepler came up with the laws. Newton said gravity is the reason why objects attract each other. That's why you get elliptical orbits. That all worked nicely. Mathematically, it worked out well. But there was still this question about, okay, but I've got two objects here. Why should they attract each other? What is going on to make them attract each other? It's the force of gravity, but what's that? Einstein took it this one step further, and he said, well, gravity, objects, massive objects, actually deform space. In the end, what Einstein did was pull together the ideas that had been building from Ptolemy to Copernicus to Galileo to Kepler, and trying to understand, well, and Newton, we have to remember Newton as well, trying to understand some of the physical properties of space and of time and of matter and how it interacted. It's another step in the chain of reasoning to understand the fundamentals of how nature works.